All right, welcome to lecture 29, part C, last part of this video. All right, so in this part, we're going to work on how can you determine the concentration. And when I say concentration, really I mean molarity of an acid or a base. So before we talk about that, let me just tell you, like, why would you even want to determine the concentration of an acid or a base? Well, pretty much every product that you eat or you drink, if you want it to taste right, it has to have just the right amount of acid or base in it. So this is actually a super common thing that's done in the world. Like for example, in wineries, we have some wineries in this county. They want to make sure the wine's gonna, have the right taste to it, or figure out if it's too sour or whatever. So they can figure out what's the concentration of acid in the wine. Or if you have some sort of, I don't know, shampoo or conditioner, you might want to make sure that it's not too acidic or basic, because if it is, it might, it might irritate their skin or whatever. So determining the concentration of an acid or a base, this idea, it's done all the time. Now, before we get into how to do that exactly, I need to remind you of a reaction that we saw earlier in the semester. So let me flip over and let's talk about a reaction you saw, well, weeks ago now, but it comes up again in this chapter. Now that reaction is the reaction between an acid and a base and how they neutralize one another. So when they neutralize one another, we talked about this earlier this semester. Let me kind of write it out generally first, and then we'll look at some examples. So generally what we're going to do is we're going to have an acid. So just to remind you, an acid is a compound that starts with H, and you're going to react it with a base. Now, a base typically ends in OH. I guess we're kind of thinking of like how Arrhenius thought of them, right? And what will happen in an acid-base reaction is the hydrogen from the acid and the OH from the base, they're going to get together and they're going to make water. Now, you might remember when we talked about this earlier, I said, one way you can write water is HOH, and then the middle guys will get together and there'll be some other product. All right, so, well, let's look at a specific example. So like, for example, let's say I wanted to, well, let me show you an example here. Let's say you could take a hydrochloric acid and react it with sodium hydroxide. Now, again, I know this was forever ago, but do you remember like in these double replacement reactions, you had to know the charges because you had to figure out the formulas of what we're making. And the way you knew the formulas of what we were making was based on, keeping those charges balanced. So in the interest of saving us a little time, I'm not going to go through and show you all these charges in the periodic table. Let me just remind you, though, hydroxide's -1, sodium is +1, chloride is -1, and hydrogen is +1. And when we learned acid-base reactions, we said, oh yeah, the outer fellows are going to get together and the middle fellows are going to get together. And when they get together in this case, it's not too bad. Hydrogen with your 1 charge and hydroxide with your -1 charge. Oh yeah, that's the HOH. That's the water. And then the middle guys get together, but you got to reverse the order. Sodium and chloride in this case. And again, it's not too bad this time because +1, -1. That works out. So it's just going to be NaCl. All right. So, and actually in this one, it's not bad at all because all the coefficients turn out to be 1. All right. So acid-base reactions, you always make water and then something else. In this case, the something else would be salt. All right. I should show you one more, slightly more challenging, huh? Let's do one that's slightly tougher. Let's say I was to do this reaction. Potassium hydroxide with, let's do sulfuric acid, H2SO4. All right. So we're going to do the same thing, right? So we're going to put our outer guys together. We're going to put our middle guys together. When you put them together to determine the product, you got to know your charges. Oh, let's see here. Again, I'm not going to bust out the polyatomic list in the periodic table. I'm just going to tell you. Okay, SO4, that's sulfate, that's -2. Hydrogen is +1. Hydroxide is -1. Potassium is +1. All right, now let's put them together. Mr. Potassium and Ms. Sulfate. That's the outer guys. Middle guys, hydrogen and hydroxide. All right. Oh, I had to flip the order there, didn't I? Because you always put the positive thing first. All right. So what are the formulas going to be? First thing, potassium and sulfate. K2SO4, because you need another potassium to balance out those charges. And then hydrogen and hydroxide. Oh, that's just going to be HOH. Oh, yeah, we always got to make water. That sounds right. We always got to make HOH, or H2O if you want. Now, in this case, this time, again, I've made it slightly more challenging because, you know, if you want to write it perfect, you have to balance it. Again, in the interest of time, I don't know if I'll go through it all in total detail, but to balance it, I think you need a 2 here, and you would need a 2 in front of the water. Make this just a little bit better. Oh. Okay, it would look something like that. All right, so these acid-base reactions, these are the ones that we're going to end up doing when we try to figure out the concentration of an acid or a base. So we're getting to how to do that exactly in a minute, but basically it's always going to involve an acid and a base reacting. And when they react, we're always going to be making water and something else. And just like we saw a minute ago, you know, it's going to be related to stoichiometry, honestly. So we're going to have this reaction written out, and we're going to have it balanced. All right. So with that quick review of these reactions, let's talk about how exactly do you figure out the concentration of an acid or a base? Well, basically, you're going to need the concentration of one of them. You'll be told, you'll be given the molarity of one thing, and you'll be able to figure out the molarity of the other thing. Now, this kind of an experiment where you know the molarity of one compound and you're solving for the molarity of another, it has a name. It's called titration. So let me define it exactly. So in a titration, it's just an experiment based on an acid-base reaction, the ones we just looked at, that is used to find the concentration, well, we'll say find the molarity of an acid or a base, of an acid or a base. Now, I should tell you, usually if we met on campus, you'd be doing this experiment. If you're taking the lab right now, the online version of the lab, you're going to do something kind of similar using your lab kit. The setup is a little bit different, so I'm going to be explaining it kind of using the equipment we would normally use if we're meeting on campus. All right, so first thing you would do is you would get out some container. Now, this container is like a flask, and in the flask, you're going to put something that typically you don't know the molarity of. So it could be an acid or a base. So we don't know the molarity of this thing. Now, what we're going to do is we're going to add into it a compound that we do know the molarity of. All right, and the way we do that is we use a long cylinder looking thing that's called a burette. So a burette is just used to measure the volume of liquids. So it's kind of like a graduated cylinder, except, you know, it's even more accurate. And so you can kind of, in this photo, you see the very end of the burette. There's like a little valve, and that little valve allows you to add small amounts of liquid. So let's just say, for example, because this is what we're going to do in a minute, let's say, for example, down here in the flask, I put some vinegar, all right? And I don't know the concentration of the acid in vinegar. So what I would do is, vinegar, by the way, is an acid. It actually contains acetic acid, to be exact. What I would do is I would put into a burette something that's going to react with that acid. So a base, in other words. So in the example that we're going to work on in a minute, we imagine that, let's pretend we used, I don't know, magnesium hydroxide. And we put it in the burette. Now, we would have to know the concentration of it. So in the example we're going to do in a minute, we're going to imagine that that magnesium hydroxide is 0.85 molar. So we're going to add the magnesium hydroxide slowly into the flask, and the acid and the base are going to react with each other. Now, when they react with each other, they're destroying each other. Now, let me write out that reaction. And again, in the interest of saving us a little time, a little heartache, I'm just going to put it up here, right? So it's we got our vinegar. This is our vinegar. It's acetic acid, really. And it's reacting with magnesium hydroxide. Now, as we just talked about, you're going to always make water. And you're always going to make, in this case, the other product would be like magnesium acetate. Now, as this reaction goes on, eventually there's going to be a point where all of the acid that's down in this flask gets destroyed by the magnesium hydroxide. That point is called the end point. So let me define that. The end point is when, we could say, when the reaction is over. Now, a better way of saying that, it's when the moles of acid and base are equal. So the reaction will be done when there's just enough acid and base around that they have killed each other off and formed water. All right. Oh, I just noticed I didn't balance this thing, did I? When you really need a 2 here and a 2 here. Okay. So when that happens, the reaction is done. Now, how are you going to know when that happens? Well, the way you know when these guys have totally destroyed each other is you add another compound called an indicator. An indicator, let me define that word too. An indicator is just a substance that changes color. We'll say when an acid-base reaction is done. When an acid-base reaction is done. All right. Now, the most common indicator we use is an indicator called phenolphthalein. And what it does is it turns actually pink when the reaction is finished. So that's what you're seeing in these photos. So they're adding more magnesium hydroxide from the burette. It turns a little pink. It actually, when it turns light pink, that tells you the experiment is over, that you are done reacting away all of the acid in the container. All right, so again, if you're in the lab, you're going to do something kind of similar. You're going to use like a dropper instead of a burette, but it'll be the same idea. All right, so with that little introduction, let's talk about, well, this is what's going on. The whole idea is let's calculate the molarity of the vinegar. So how do you do that? All right, so, well, you're going to need some numbers, and let me give them to you on the next slide, and we'll try to work out what the heck would be the concentration of this vinegar exactly. How would we find that? Okay, so the question, now we have some numbers. We'll be able to do some calculations with these numbers. Suppose we have 8 milliliters of vinegar, which contains acetic acid, and we want to know the molarity of the acetic acid. All right, what's the concentration of this vinegar, right? So if you're going to make vinegar, you don't want it to be too concentrated. Nobody's going to buy it. You don't want it not concentrated enough. Nobody's going to buy it. So we want to know what's the molarity of this sample. So we titrate it with 0.85 molar magnesium hydroxide using a burette to slowly add the base until the acid was neutralized. So what is that trying to tell me? So that sentence is telling me, kind of like I talked about a minute ago, you get this long cylinder. It's called a burette. We're putting the magnesium hydroxide in it. And we are using, they tell me that we're using 0.85 molar magnesium hydroxide. Okay. And then they say, the other number that's important, we apparently have 8 milliliters of vinegar. Now, it didn't say exactly where that 8 milliliters of vinegar is, but it would be down underneath the burette. You have 8 milliliters of vinegar. All right, that's what I've learned so far. All right, let's keep on reading. If the 8 milliliters of acetic acid were neutralized by 24 milliliters of magnesium hydroxide, what's the molarity of the acetic acid? What's the concentration of that vinegar? All right, so it was neutralized by 24 milliliters of this stuff. So this is typically what we're going to have. We know actually you're usually going to be given the volume of both chemicals, the acetic acid, the vinegar, and the magnesium hydroxide, and you're going to know the molarity of only one of them. This time, that is the magnesium hydroxide. I am looking for the molarity of the other one. All right. Now, it's going to involve a little math, but before we can even do the math, we need to write out the reaction. So let me go ahead and write it out. And again, I wrote it out a minute ago. I'm just going to rewrite it. Let's see here. You would get, my acetic acid is reacted with my magnesium hydroxide. And you get 2 waters and 2 magnesium acetates. Okay. All right. So we have a reaction written out, and even better, we have it balanced. That's super important. Okay. So let me kind of outline what we're going to do. So the first thing we're going to do, if you think about pretty much every stoichiometry problem we've done all semester, it involves moles. So the first thing we're going to do is we're going to figure out, we're going to find our moles of our known. So our known is the thing we know the most about. The thing you already have the concentration of. That, in this case, is the magnesium hydroxide. So you know the concentration of the magnesium hydroxide, and you know how many milliliters it is. So the way you can find how many moles you're using of magnesium hydroxide in this example is, you can say, this works, you can do molarity times liters will tell you how many moles you have of this compound. Now you might ask yourself, well, how does that work? Well, let me remind you, what's molarity? It's really moles over liters. So if you multiply it times liters, molarity times liters, oh, the liters cancels. Yeah, that's why that works. That's why that's going to tell me how many moles. All right, let's do it. The known is the magnesium hydroxide. Take its molarity, multiply it times how many liters you're using. Now, wait a minute. I told you the amount in milliliters. So you got to convert to liters. So the way you would do that is you would, oh, do you remember we've done this recently? Oh, you divide by 1,000. I'll write it out right here real quick, and I probably have to erase it in a minute because I need all the room I can get. But if you divide by 1,000, how much of that stuff are you using? Magnesium hydroxide, you're using 0.024 liters. That's how much. All right, so that is our liters. Now, if you work it out, when I did this earlier, the moles of magnesium hydroxide, I used 0.0, let me check my notes, 0.020 moles of it. Oh. Let me make this better. It should have a 0 on the end, actually. 0.020 moles of magnesium hydroxide. All right. Good, good, good. All right, now what we're going to do, again, this might sound a little familiar from stoichiometry. We're going to go from moles of one thing to moles of the thing you're solving for. So the next step is we're going to find moles of the unknown. Now the unknown, hey, that's what I'm asking you about. I wanted to know the molarity of this acid that's in vinegar. All right. All right, now to work it out, we've done this before. Moles of one thing to moles of something else. What do you use? Coefficient. So yeah, not in a while, huh? But yeah, it's the coefficients. So you would take your moles of magnesium hydroxide and you're going to go to moles of acid, moles of acetic acid. All right. Now, let's see. My coefficients are, for every one of these, there are 2 of those. So I'm going to put the coefficient of what I know on the bottom. That's the magnesium hydroxide. I'm going to put the coefficient of what I'm solving for on top. All right, I'm having to fit this in here. I apologize. It's getting a little messy. I'm assuming you can read that. All right, now if you work it out, you basically are going to multiply by 2 and divide by 1. If you do that, hey, how many moles of acid are there? It's double. So it's going to be 0.040. All right, 0.040. All right, we got one more step. Now, I'm going to need to erase, so you can pause it for a sec if you need to, jotting this down, because I got to erase a little bit at the top to do the last step. All right, now we know how many moles of acetic acid there were. What's the molarity of it? So one more step will get us that answer. The way you can find molarity, step 3, I guess we'll say find molarity of the unknown. Oh. Now, to do this, how are we going to do that? Well, what the heck is molarity again? Molarity is moles over liters. You have both of those numbers. Moles of acetic acid. Oh, we found that a minute ago. 0.040. Liters of acetic acid goes on the bottom. Now, actually, you know what? Actually, we don't quite have that, do we? You know the volume of that acid, though. That vinegar, it's 8. We need to convert it to liters. How do you do that again? Oh, milliliters to liters. Man, we've been doing this all the time recently. You divide by 1,000, right? So let's go ahead and do it. You get 0.008. So that would be our volume. It would turn out to be 0.008 liters. That's after we converted. Now, if you work it out, you would get an answer of 5 molar. All right. So hopefully that makes sense. I'm going to do one more in this video. The next one, you're going to help me a little bit. So if you're not quite ready to help me out with one, you can always watch this part again or look over these notes to hopefully make it sense. All right, so let's try one more example. I want to know the molarity of an acid or a base. You could do a base the same way. And we're going to do that. When you try to figure that out, that's called a titration experiment. All right, let's try one. Let's try one last one. Okay, so our last example for this video. Determine the molarity, determine the concentration of KOH, I guess that's potassium hydroxide, if 120 milliliters of KOH is neutralized by 235 milliliters of 0.57, I guess that's phosphoric acid. Okay, so we're trying to determine the concentration of something. Step 1, you better have the reaction that's going on, and it better be balanced. All right, I'm going to go ahead and write it out for you, save you a little effort and time, but you got to have the reaction. So the reaction that's going on, we're reacting a base with an acid. Let's go ahead and write it out. So it's going to be KOH is reacting with phosphoric acid. Now, again, in the interest of time, I may not prove all this to you, but if you balance it and you write the products, well, you know one of them's going to be water, right? It's always water. And then the other one, if we worry about our charges and all that mess, would be K3PO4. Does that look right? It should be. All right, and then you got to balance the thing. And you got to need a 3 here and a 3 here. All right, we got the balanced reaction. Okay, now that we have the balanced reaction, let's start thinking about what all these numbers they're giving us mean. Determine the molarity of the KOH. Oh, I'm looking for this. If 120 milliliters of KOH, oh, that's how much we used, is neutralized, reacts with, another way of saying that, 235 milliliters of 0.57 molar sulfuric acid. All right, so we have one molarity. We're looking for the other one. You do need to know the volumes of both. There could be some weird questions where you're given slightly different information, but this is kind of the most common kind of problem. All right, so let me outline the steps, and then I'm going to get you to work on them instead of me. Why am I doing all the work? That doesn't make any sense, huh? You got to do something too. All right, find moles of known. The known is the thing you know the most about. That's the acid this time. Find moles of unknown. The unknown is the thing you're solving for, the KOH. And then the last step, you can find the molarity. All right, so that's the basic outline. All right, so I'm going to see how this goes. I hope it's making sense. Let's double check. All right, first thing you're going to do, you could look back at the last example if you're not sure. Find moles of phosphoric acid, the known. All right, I'm going to give you a second, a little pop-up. What's the right answer? All right, let's see how you did. So the way you can find moles is if you have a molarity and a volume, you multiply them together. Now, oh, there's only one tricky thing. It's molarity times liters will give us how many moles we have. So now the molarity, oh, that was easy, or not, well, I was told to you at least, huh? Now the liters, not so much. I gave you milliliters. So you'll have to convert the 235 milliliters to liters. Oh, we do this a bunch. You divide by 1,000. So molarity times liters gives you moles. So when you worked it out, I hope you got, oh, I gotta check my notes. I hope you got 0.13 moles. All right. Next step. Next step, you're going to go from moles of what you know. That is the acid to the moles of what I asked you about. That is the base, the KOH. Hey, moles of one thing to moles of something else. What do you use and what's going to be the answer? Oh, think about it. All right, let's see if you got it right. So the moles, let's see here. So for every, oh gosh, let's look at our balanced reaction. That's why we wrote it out. For every one of them fellas, there are 3 of them fellas. 3 on top. All right. And if you work it out, you should be getting, oh, you should have gotten in this step, 0.39. 0.39. Okay. All right. Now we're in the home stretch. We now know how many moles of KOH. Now you can find the molarity of the KOH. Let me get you started. Let me remind you. Molarity is moles over liters. Let's be a little more specific. Moles of KOH divided by liters of KOH. What are you going to get when you work that part out? What's the answer? Oh, let's see what you got. So you take your moles. Oh, that's the number we came up with a minute ago. That's the 0.39. And you divide by the volume. The volume of the KOH. Now, what number was that? It's the 120. But again, darn units, huh? 120 is milliliters. You got to get to liters. Divide by 1,000. We'll do it right here because this is the only spot I have room left. Oh. So you divide by 0.120 liters. All right, if you worked it out, the final answer, which you should have gotten in this last step, should have worked out to be 3.3. 3.3 would be the molarity. All right, hopefully that makes sense. I know there's been a lot in this lecture, right? So it was a little longer than some of them, huh? So this is as far as we're going to get in this part, though. If you're stuck on this, we'll practice this in Zoom more. We'll get you some more practice in, or you can email me or whatever, and I'll help you out the best I can. Hopefully it made sense. If not, oh, you still got some more time to figure it out, and I'm here to help you with that. All right, so I'll talk to you next time on the good old internet. Bye-bye for now.